All right, folks, today we're going to be talking about relations and special types of relations, which we call functions. So you'll label the top of your notes, understanding relations and functions. We're going to start out with some definitions, just so you can understand what a special type of relation is called. Very special type of relation that we're going to be focusing on today is a function. So a relation is just a set of numbers. A function is a special set of numbers. So if we zoom in here, let's talk about the definition of a function. All a function is a relationship between two numbers that we call x and y. A relationship between two variables, which we typically use x and y, where every input, which is usually the x, has a unique output, which we use the variable y. In other words, the x values are not repeated. If it's going to be a function. So I wanted to look at some real world examples of this so you could see, that's all a function is. An example of a function is a student and their locker number. So let's say we have Gus, Allie, Grant, and Amy. Gus goes to locker 1, Allie goes to locker 2, Grant goes to locker 3, Amy goes to locker 4. Each person, each input, has a unique output. In other words, Gus does not go to locker 1 and locker 2. If Gus went to locker 1 and locker 2, that would not be a function. So this is an example of a function. If you toggle over to the right, a non-example would be like a street address being an input and an output being a family member. So like, let's say that you live at 100 Main Street. 100 Main Street could be mom, could be dad, could be bro, and sis. Do you see how this input is repeated? It has multiple places to go for the output. This is a non-example. So we would say that this is an example that is not a function. Whenever the input repeats to multiple outputs, that is not a function. Like I was saying before, there are inputs and outputs. The inputs of the function are just the x values. So another word for the input of a function are the x values. We refer to these x values, or the inputs of a function, as the domain of the function. The outputs are the y values. Another word for output is range. So if we go down to this box at the bottom, if we're focusing in on domain, another vocabulary word, the domain is the complete set of inputs or x values. So when we're finding the domain today, we're going to be given a list of points, and we're going to determine what the domain is. So we're just specifically looking at the x values. So if we look here, if we want to state the domain, we're only looking at the x values of these points. Since it's just a list of numbers, we're going to list those using brackets. So we would say that the domain, the list of x values, would be 1, 2, 3, 4, 5, 6. Now, this would be a function. It doesn't ask us this, but I'm just reviewing. We would say, yes, this is a function because all the x values are unique. If you toggle over to the far right box, when we're talking about the range, if we're asked to find the range, it is just the complete set of outputs, or the y values. So we're just going to look at the y part of the ordered pair to find the range. One, 4, 9, 16, 25, and 36. We'll be talking about domain and range a bunch this week, so make sure that you're getting those vocabulary words in your head. Domain is x values, range is the possible y values. And the domain is the one that determines whether it can be a function or not. The range doesn't affect whether it's a function or not at all. It's all about the inputs. Okay, let's flip to the back. All right, let's take a look at a word problem talking about domain and range. We have Taylor, and she's getting ready to go through the automatic car wash with her mom. Taylor's mom gives her several dollar bills and tells her to use it to get quarters for the car wash. Taylor puts $1 into the change machine, and the machine gives her 4 quarters. She puts another $1 in the machine, and it gives her 4 more quarters. I should say Terry, not Jerry. Taylor continues until she has 26 quarters. It should also be 28, not 26. But as she walks back to the car, she begins to think about what she put into the change machine and what came out. So in our little example here, she puts in 1 quarter, she gets 4 quarters. She puts in $1, she gets 4 quarters. $2, she gets 8 quarters. 3, 4, 5, 6, 7, and so on. So the inputs, if we're trying to figure out what the input represents, what is she putting into the machine? Well, the input, she's putting into the machine dollars. The output, well, what comes out of the machine? Quarters. If we're trying to find the domain, we're just listing off the possible x values. So she put in $1. She could put in 2, 3, 4, 5, 6, 7. That's what she went up to. That's our domain, what the number of dollars that she put in. The range is the output, the number of quarters that come out. So if she put in $1, she got 4 quarters. $2, she gets 8. Then 12, 16, 20, 24, and 28. Remember that the range is coming from the y values, the output, the number of quarters that she got out of the machine. Now, if we're trying to determine if it's a function or not, remember to think, do we care about the domain or do we care about the range? We care about the domain. So if we're determining if it's a function, we look back at our domain. Do any of these x values repeat? The answer is no. So we would say, yes, this is a function. The x values do not repeat. Now I want to make sure you understand why it's a function. If you put in $1, you're not going to get anything other than 4 quarters. If, on the other hand, you put in $1 and you got 4 quarters or 8 quarters, that would not be a function. But because every input has a unique output, that is why it's a function. Now, there are multiple ways that we can represent a function. We can represent them with a table, with a map, or on a graph. So we're going to use that example above to practice representing a function in different ways. So a table, a simple XY input-output table. You list your domain on the left. So our domain in the last one were all the numbers from 1 to 7. And you list your range on the right, 4, 8, 12, 16, 20, 24, and 28. When you're looking at a table and trying to determine if something's a function, you look, you look at this x side and you make sure that all those x values are unique. The next way you can show a function is with a map. A map uses two ovals and arrows between the input and the output. On the left, you'll have your inputs, and on the right, you'll have your output. So we'll put all of our inputs, all of our domain on the left, and all of our outputs on the right. Then the final thing that you'll put in a map are arrows. So this one is going to be pretty basic, but you'll draw an arrow from the input to its created output. So if you put in $1, you got 4 quarters. If you put in $2, you got 8 quarters. So on. $4, you get 16. 5, you get 20 quarters. 6, you get 24 quarters. 7, you get 28. Now, again, if you were trying to look at this and determine if it was a function or not, you would look at your inputs. You would want to make sure that each of these inputs only has one arrow coming from it. We do not care about the outputs to determine if it's a function. We only care about the inputs. Last, you can use a a graph. We'll go down to that. We're going to start by making sure we label our axis. So on our x-axis would be our inputs, and in this case, our inputs were the number of dollars, and the y-axis represents the number of quarters. Then we will simply plot each of our inputs that goes with its coordinated output. So if we put in $1, you got 4 quarters. If you put in $2, you got 8, 3. We got 12 quarters. 4, 16, 5, we got 20, 6, we got 24, 7, we got 28. Now, I want to point out something here. Whenever we see dots, it's like we go back to being kids again. We want to connect the dots. However, make sure in this example that we don't connect the dots or the points. And I want you all to think for a second why. Each of those points represents an input that goes with an output. If we connected them, we're saying that we can put in 1 and a fraction of a dollar and get out some fraction of a quarter. You can't put in part of a dollar. Cannot put in part of a dollar and expect to get a whole number worth of quarters out. So this is a special type of graph, which we call a discrete graph. We'll be talking about it later in the week, but make sure that you're thinking through whether you should connect the dots or not. And in this case, we do not connect the points. So the main point about today's notes, what's unique about a function? The x's must be unique. In other words, they do not repeat. So we'll check that out in map form, in point form, in graph form to make sure that it's a function by looking at the x's. Now, we're going to specifically turn now to how do we tell if something's a function based on the graph. Remember that the x values have to be unique, so we do something, a special test called the vertical line test to test if the x values are all unique. And this is what it says. Remember, vertical goes up and down. Horizontal goes like the horizon, side to side. So the vertical line test says if the vertical line touches once in each place, then it is a function. If, on the other hand, the vertical line touches more than once, we would say it is not a function. So let's try it out with these examples down here. It says determine with your partner, but that's assuming we're in class. Since we're online, we'll just do it together. Determine if the following are functions. Explain why you think they are or not functions. So we're going to take a vertical line, I'm just going to use it. If I was in class, I would use a pencil to show you. But we're just going to take multiple vertical lines across this graph. Now you'll notice each vertical line only touches the blue line once. No matter where you are in that graph, if you draw a vertical line, it only touches once. So we would say that yes, this is a function. Reason being, the x values are unique. Looking at the one to the right, if you draw a vertical line right down the middle, you'll notice that it touches more than once. Touches here, touches here. That is not a function. Reason being, this x value, no matter what it is, repeats. So let's just say it's like, I don't know, 4, 2. This would be 4, negative 2. That x value would repeat itself, which makes it not a function. Let's do one more together to the right. Draw some vertical lines down that graph. You'll notice that no matter where you are, it only touches the blue line once. So we would say that yes, this is a function. The reason being, the x values are unique. I want you to go down to the 3 problems below there and try those on your own to determine if they're functions or not, and I'll unpause the video and you can check your work. All right, check out your work on these last 3 problems. You should have gotten that the first one, because it just was completely repeating all of these x values of 5, it was not a function. So the first one is no. Second one, you drew a vertical line in many different places. You'll notice that it is no, not a function. Those x values are repeated. If you needed to even list out the points, like this is 1, like negative 2.75, and then 1, 2.75. That 1 is repeated twice, not a function. And then our last one, no matter where you put that vertical line, it only touches once. So we would say, yes, that is a function. Your homework will go over determining if things are functions, whether you're given a map, a table, a graph, so that you can practice that. Log back into office hours if you have any questions.